Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
Oh, welcome to the Math Map Book Club. Today is March 11th. It's Wednesday. And I want to just thank our team, not just Kirsty Gilpin and I, who get together each week to discuss the Math Map that's used in the Classical Conversations curriculum. But during this Easter season, to thank our team for helping math to rise again, to glorify our Lord and Savior Jesus Christ, and to not be something that's just there so you can get a good STEM job, which of course we know seek first the kingdom of God and his righteousness. And guess what? Everybody gets a good STEM job. So thank you for being here. And Kirsty, what do you have for us this week?
Well, this week we are looking at lesson 27, complex numbers. And I think it's really exciting because a lot of people jumped into the complex domain and they think this is really hard to start here. And this is a really great reminder that eventually this is not where everybody will start. That in the complex domain, that everybody's going to have had an introduction to complex numbers all the way through, from our youngest learners all the way up, so that we see the fullness of the numbers that God has given to us. And we include it here because this is the start of a new dimension, the nth dimension, which we have called imagination space. And I always like to take a minute to really say there's a difference between imagination and make-believe. Make-believe is Santa Claus. Make-believe is something that's not real and we pretend that it is. And that can be good, right? It can be a good thing. Make-believe isn't bad, but it's not something that's real. Whereas imagination is interacting with ideas that we can't experience with our five senses. And so they can be things that are very, very real, but we don't see them with our eyes or hear them with our ears. We have to use our imagination. It's a different sense that we use to picture things. So complex numbers are kind of just that. They're numbers that don't measure something in our real world. They have this extra dimension to them, the imaginary dimension, where we know that they exist. They solve a lot of issues in mathematics. They are very, very real things in terms of having existence, but they're, again, have that extra dimension that we can use our imagination to see. Every week, we like to talk about our strategies for flashcards. As we are tailing towards the end of the year, I'm going to combine a couple of them this week and talk about mixing decks and students choosing cards to review the lesson, because they really do go together well. I actually spoke with somebody this week who confessed that they had taken this huge step of taking all of the cards out of their boxes and mixing them up. And that's a big deal, right? Because you're like, these are in sets, and we really want to encourage you to be able to go, no, I'm going to pull together these ideas because they're all integrated. They all interact with one another. And so being able to take those decks and pull them apart and pull out the things that are specific to what you're learning is a great way to use your flashcards. And by inviting your students to choose the cards that are going to review that lesson, you're involving them in learning how to learn for themselves. Right? So we can always choose for our students which flashcards they need to review, but when we invite them into that process, we're helping them to determine what's the important grammar that I need to know, how can I practice that, so that when that day comes and we're not there to hold their hand and tell them what to do, they're prepared to do that for themselves. So does anybody have anything they'd like to share about flashcards this week? Kristen, have you survived mixing up all your flashcards?
I have them on my lap right here, and they're very organized, but they're not organized, but it's okay. I'm okay. Babs, I I relate to you. I took a big step this week and I mixed them all up. So,
You're better than me. I have not done that yet. But I tell you what I did do. I bought I saw this somewhere else with a different for different cards, but I bought the little sleeves that you put baseball cards in and a binder. And I thought about if I could mix them up, I might would put them in something like that so they would still be organized. Like I could put things that are similar in, sleeve pages, but they would still be out of the box and mixed up with other things. So I have taken that step to maybe try, but I haven't done it yet.
well, the epiphany that I had, it was well into my foundations years. Every cycle, we would have cycle one, and I take out my cards and I would go over with my young kids at the time, and I would shove cycle two and cycle three under my couch. And I would wait for cycle two to roll around, and then I'd pull out cycle two and put, cycle one under the couch. And then when I found this whole memory box idea of reviewing everything all the time, it just made such a difference. And I mean, even into the challenge years, I would have my kids go back and review challenge, or foundations information. And we still do that in challenge four. I still say, okay, we're on Newton. What's Newton's first law? What's Newton's second law? What's Newton's third law? And they're so excited to be able to recall that and say it in class in their challenge four. So it's fun.
I love that, Kristen, because that's exactly, and Lee, correct me if I'm wrong, but that was exactly what I thought CC was all about, was that we're memorizing this body of knowledge and foundation so that we could use it in challenge. And so if we aren't helping our parents to intentionally see those connections, they may miss out. So I love that you're doing that, Kristen, to really help them see how valuable that practice was up front. Looking at our cover and using our 15 skills. So this week we're talking about our core habits and our acronym of names to help us to remember that. And so we can name the parts of the cover. Again, hopefully after the first couple of years, students are going to go, I know what they are. But it's always good, especially on a new dimension, to take a minute and say, okay, what are the parts of your cover? Right? Oh, look, there's my dimension. Oh, do you notice something? It changed. We're in a new dimension this week, right? What's your domain, right? We've been in this domain a long time. As you start getting toward the end of the year, you could start casting that vision of, well, what will next year's color be, right? When we look at the math map page, let's think about what would next year's color be? What would next year's symbol be, right? What's our title? Complex numbers. What's the number? 27. My students used to, I'm sure, really appreciate the fact that I would always do the fractions every week. So if we have 30 weeks and this is week 27, right? Let's simplify that, right? Well, 3 goes into 27 9 times and into 30 10 times. So we're 9/10 or 0.9 or 90% of the way through. Right. So here's a great way every week, especially when you know that it will simplify, to take that fraction and practice fractions with our older students. And somehow there's a difference between being on week 27 and being 90% of the way through your year. Right. So, and then what are our other parts? We've got the math map down here. We've got our artwork. We've got our title. We've got our reflection, our quotation and our reflection. So just going through and naming the parts of the cover reminds our students of the richness of ideas that are just here on one page. And when we think about our exordium, we heard from somebody this morning that said, well, I ended up asking the same questions that the B tutor and the A tutor, it was one of our pilot tutors, have asked. And the kids are like, well, we've answered that question. Right. Well, there's so many parts of this cover that if your students are maybe not that excited about the art, or you don't have another question about the art, you can ask about the week. You can ask about the dimension. You can ask about the domain or the reflection or the quotation. There's so much on here that you can use as your exordium to have that conversation, whether that's at home or whether that's around your family table.
Something I think we can do to help our older students self-assess when because I hear this from some of the kids myself that, I know the five common topics, but backwards and forwards. So now they're going to know names, backwards and forwards. So when you get that kind of sense and you're a challenge 2, 3, 4 tutor, say, great, I'm sitting down. You go ahead and lead the class through the names. Because what it reminds me of is I so very often think I know the words to crown him with many crowns or how great thou art. But then when I try to go sing it by myself, I realized, I was being arrogant. I don't really know it. And so that's a good way to help the students to see what they really do. Because it's just five things. I'm guessing a lot of them do really know it. And then you can say, great, I don't need to call on you again. Who needs more work? And so it's a way to engage the class without just being repetitive from the tutor's level, because otherwise that begins to feel didactic, which is what we're trying to avoid in those 1 day a week meetings.
That's great.
Mhm.
So when we think about attending, a lot of times we have to use our imagination in order to attend, right? Because we're looking and we're trying to be really careful, and we might be thinking about what are the patterns that I'm looking at, right? Attending is something that goes along very closely with pattern finding because we have to be careful. And when we're looking for patterns, that's using our imagination because we're finding what's the hidden bridge between things. This particular piece of art is a great piece of art for looking at patterns. And so when you ask your students to attend, we have to be careful. We have to look really carefully here in order to discover what some of the patterns are in this art. Memorizing, again, looking at your covers and thinking what things on the cover. So going back, we've named some parts. What are some of those things that you could memorize? Our domains and our dimensions. Lee has often said in your first year through the math map, if you just know what the domains are and you just know what the dimensions are, you can rebuild, right, a good chunk of the math map and know where you are. And so asking the students, well, we're on ND. What are the other dimensions we've done? Have you memorized those? We're in monomials. What are the other domains? Can you list them? How many can you list? When we think of expressing, it's usually tied to creating some kind of artifact or some kind of movement. Right? Expressing is that more nonverbal thing that we're doing. So when we look at our art, we could say, what kind of art does this image inspire you to create? A student might look at this and think, well, I don't want to just create another picture. This makes me think of a seashell. So maybe I want to create a seashell out of clay or Play-Doh. That they might see this and be inspired to create or express that idea in a whole different medium. So asking them to think about that is a great option. And then for our storytelling, thinking about the parts of a story, you can always ask them, what kind of plot could this image match? For some reason, when I look at this particular piece of art, I always think of Jules Verne and something like Journey to the Center of the Earth, right? And so I think about, we're going down into something. But that would be a really fun thing to ask your students and have them all come up with a different plot or build on it, right? Sort of those games where you all kind of add a word. Right? So I might say there was a group of 6 people, and then Babs has to add to that, and then Kristen has to add to that, and Lee and Hallie. They're all adding to the story, right? But the story has to somehow incorporate the art. That would be a fun thing to do, whether that's at home or in a group, right? You could really have some fun with that. That would be a great bedtime story type of activity. If you are a family that reads together at night, maybe instead of reading together at night, create a family story using your art that day. And then also on your first day of the week, we encourage you to take a look at the math map And again, we are in a new dimension, our last dimension, and it is called ND, or imagination and space. The N means that it can be any dimension. So a lot of times people look at this and they go, oh, it's infinite dimensions. And it could be, but it can also be 0D or 1D or 2D or 3D. We're finishing the year by saying, what are some of the patterns that would hold for any dimension? We aren't really trying to ask you to do 100 dimension math. Or I was looking it up this morning that the latest string theory is called M theory, and it uses 11 dimensions in order to explain how the whole world and the whole universe works together. They need 11 different dimensions in this particular theory, right? We're not doing that, right? But we are asking our students, what are the things that, if there were 11 dimensions, what are the things that would have to be true? And then let's go back and take a look at some specific two-dimensional ideas and some thinking processes and talk about how those patterns are going to help us to see the unseen. So that's how we're ending the year. It really is this nice wrap up as we finish the year, and it's a great opportunity to go back and revisit what are these patterns that we've been looking at since week 1. On our first day, we always like to give you some ideas for the lesson pages, and this week we're talking about prioritizing skills over concepts. Especially if this is your first year in the math map and complex numbers are not familiar to you, you don't have to understand everything there is to understand about complex numbers in your first year or your second year or your third year, right? It's meant to be a multi-year process of building that understanding. So when you're looking at the week's lesson and you say, well, I don't really understand this. I know my kids aren't going to understand this. What is it that matters from this? What matters is continuing to prioritize those skills. Physical skills are a really important part of why we have booklets, why we have different activities, whether it's mathematical or any of the other strands, right? That we want our kids to be able to learn to sit still. We want them to learn to attend and to listen. We want them to develop fine motor skills like tracing or handwriting. So those physical skills develop right at their pace, but we have to give our students the opportunity to practice those. Right? If we never ask our children to practice sitting still and waiting patiently, they probably are not going to learn to sit still and wait patiently. And so sometimes that might be what we're practicing. Or we can be emphasizing our learning skills, our core habits, our common topics, our canons of rhetoric. And that doesn't mean that you have to practice all 15 every week. Now, the reality is that you probably do practice all 15 every week. That's why they are learning skills, because we're always using them. But when we say practice them, it might be that you say, this week, I really want us to emphasize naming, or I really want us to emphasize definition. Or I really want us to be intentional about comparing things on every page so that you're calling out those behaviors, you're intentionally practicing them, and helping your student to become confident that they have the skills they need to be lifelong learners. This is a great place to also talk about the fact that sometimes our academic work is also developing that internal discipline that comes from being obedient, right? That comes from doing things that we don't feel like doing. And so those character, they're not really character skills, but those characteristics that we want to develop in our students, sometimes our lesson pages are the opportunity for us to do that also. And so celebrate when we're learning these physical skills, these learning skills, or developing our character, even if we're not always mastering all of the concepts in the way that we perhaps would have thought we needed to with a traditional curriculum. Because I heard this from somebody this week, how great it was to know that they were going to come back and revisit it, that it made it so much more restful. Anybody have anything they'd like to say about skills over concepts? So looking at our lesson pages, you're going to see that there's lots of practice with the square root of -1, which can be represented by I. That is probably the biggest thing that they're practicing. There is also some, you'll see in monomials, right? They're starting to do some more calculations, but a lot of it is just being able to read a complex number to identify what's the real part, what's the imaginary part, and understanding that they live in 2 dimensions instead of 1.
I feel like we had a couple questions come in about the the eye and that they had never seen this before. And I want to say we saw now that I'm looking at monomials where it has memorized the pattern. I think that was on week 2 or 3 maybe.
Mhm.
And so just reminding them that yes, you have seen it before, and you might not have noticed it if it's especially if it's the first year, but as you do it every year, you'll say, "Oh yeah, yeah, we've already seen I." And so just being comfortable knowing that you're going to see it every year and not get all, excited because it's something new. I mean, I'm talking to myself because I do it all the time, but just remembering that we're going to see it again.
Mhm. The children, you can have them substitute I for tree or your eye. Because, if you have one eye plus one eye, you're going to have two eyes. If you're going to have one eye times three, you're going to have three eyes. That's perfectly acceptable for them to realize you could have called it anything. Just the eye is really weird to most of us, right? It's that imaginary number until they get used to saying, okay, so I is the square root of -1.
Well, and that's a great point, right, Lee, that you're always saying that all these symbols are just so that we don't have to say the square root of -1 every time. That I is so much easier to say. And so encouraging our students, um, is not intended to be obscure, it's intended to be simpler.
So I guess like sine and cosine, a tutor could say, or a parent in the younger grades could say, the square root of -I, the square root of -I. And then when the children's like, I'm tired of saying the square root of negative, I'm sorry, the square root of -1, square root of -1, then you can say, okay, let's just say I. I'm tired of saying it too. So just as a reminder that sine of theta actually is a three-letter shortening of a very long sentence. And you just don't want to say the sentence over and over again. So mathematicians love shortcuts, which is, of course, why it's often hard to study because you don't know why the shortcut's there.
On day 2, we encourage you to take a look at our I² invention page, which is there to practice the 5 common topics of invention. And we intentionally chose this year to highlight one common topic every week because we really want you to know that you don't have to spend all day on all 5 common topics on this page, that you can pick one common topic that you want to examine and take a look at the page. And sometimes it may feel like there's one particular topic that matches that page that you want to practice. But other times it might be helpful to go, well, for example, how does authority and testimony help us with this page? Right? What on this page is an authority, right? What is telling us something I need to learn?
So I think a page that's this unfamiliar is all authority. Like, because I don't understand it, I'm only believing it while I'm practicing the grammar till I get to understanding.
Right. And so that's where I think if we help our students to see that I can take even the hard common topics and still ask questions that's going to reveal something that the other common topics wouldn't have revealed. And that's what we're practicing. Any questions on this particular I-squared invention page?
I don't know if you can say this briefly. I haven't done this one yet this week. But Babs, you were right. I'm pretty sure it was week 2 when they were first learning all the different types of notation for numbers that I was in there, and it's in the flashcards. So for now, all my son knows is square root of -1. But when I look at this invention page, my brain wants to see the application of I in the vectors, as well as that rotation in the unit circle that I'm seeing. Are you able to say that in briefly, or am I just asking for too much?
So multiplication is always rotation. We're never taught that multiplication is a rotation. When we multiply by 1, we're essentially going 360 degrees. If I multiply by -1, I'm going 180 degrees. If I multiply by I, I'm going 90 degrees. Right? So it's always giving me this sense of rotation, but with the real numbers, it gets hidden because I just bought back and forth between the positive and negative side of the origin on the line. Now that we have 2 dimensions, we can start to see how we get this other rotation in there. When we define a point, we have a lot of ways that we can define a point. We can talk about that point as a plus bi, its real plus its imaginary part. We can talk about it in terms of its rotation, right? So an angle of rotation, or we can use a vector, and the vector really just looks the same as it would as, but now instead of having 2 components, they're going to be summed. So my vector might be 3 plus 5i. Now, once I say it's a vector, from the origin, it would define the point 3.5i, but that calling it a vector just lets me move it around, right? Just like any other vector, the segment between 0, 0 and 3 plus 2i is always in that location, right? That segment is always there. But if I call that a vector, I can have the vector 3 plus 2i, and it can be anywhere. And that's what helps me sometimes to add different ideas together, because I can say, well, 3 plus 2i plus 3 plus 2i, I can move those vectors around, and that's the big difference. Does that help to answer that question?
Yes. And some of what you said is on the second chart, page 2. I just haven't attended to it enough.
That's okay. This is why we're here.
And Hallie, I haven't attended to it enough. It's just this whole school thing that we want to get things done. And guess what? Only Jesus gets to say, I'm done. So there's never that. I just love that you guys say that kind of things, because parents need to know it's okay that you don't know it all.
Didn't
Yeah,
we hear that
I mean,
somewhere else this week? That you can't ever know it all in math? I think we heard that somewhere else this week.
I'm not sure we can know it all about anything.
I mean, and think about how uninteresting studies would be if you never got challenged with something that made you go, whoa, I don't know what's going on. Like if you always understood everything and could always apply everything, you would be so much less motivated to learn things. I think, at least. Curiosity would be squashed.
So here's page 2. So on page 1 or on chart 1, we're really looking at the patterns that are holding true for all of our dimensions. On page 2, chart 2, and so forth, we're really emphasizing the complex numbers even more, and how they work, where they live, the different forms of complex numbers. And so that's what you see here, is again, seeing that idea that every time I multiply by I, I'm rotating, seeing those, practicing again. Here's a great example of the interconnectedness of what we're learning, because we see here we've got, it looks like trig again. Well, why are we doing that? Because there's a polar form. So all of those trig things that we learned, we need them again and again. And so it's a great opportunity to continue to practice this with our students.
I want to remind folks, because I just realized this. So we do that trig back in 16. For some things that set you up for the trig because of the ratios earlier, but we actually work on the trigs like in week 13. But it's 16. And then in 25 and 26, you're working on the trigonometric functions in their areas and their slopes. And then now we're seeing them again in week 27. So this is like 4 weeks of seeing these, over and over again. Nothing is only in one unit. We try to spread it out to give them introductions before they get to the meat of it.
So on day 3, we encourage you to take a look at the I cubed memoria and arrangement page, which is there to practice noticing or attending to the arrangement of ideas, taking things that we may have memorized elsewhere, but now seeing it in an arrangement, seeing it in context. And it's an opportunity to, again, to practice those 5 core habits of memoria. This week, we're talking about memorizing. And Lee, you can correct me, but this is always how I think about the difference between memoria and memorizing. That memoria is all of the things that I remember. And I may remember the meaning of a word, but I haven't memorized its definition from Webster's dictionary. So I may know, right? If you ask me what's outside my window, I would remember what's outside my window, and I could tell you about the pine trees, and there's an apple tree, and I could tell you, but I'm not going to. I haven't memorized how many trees. I haven't memorized how tall the trees are. I haven't memorized the distance the trees are apart, right? So my memory is broader than memorizing. Memorizing is when we really want to remember something exactly, when I want to remember details. This is a great thing for formulas, for patterns. Right? And so when we think about memorizing, we have people that think that they're supposed to memorize the charts, and that's not the intention of the charts. The goal is to add those charts to your memoria, right? And you may memorize some things, but don't memorize the entire chart. Now, you might memorize the 30 weeks of the math map, or you might memorize the different domains of the math map. Those would be lists that would be worth memorizing, right? But my memoria would be the overall pattern. How does it all fit together, right? I'm storing that in my memoria, and my memorizing helps me to have the pegs on which I'm going to build that memoria. So as I look at this page, I want to be, when I'm thinking in terms of the skill or the habit of memorizing, what I want to be thinking about is what on here are some things that I would want to remember exactly, right? What are details that matter, that I don't want to approximate? And then I can scaffold by chunking, right? Or finding smaller sections that I want my student to memorize. So for my youngest students, maybe I just want them to memorize that there is an Euler's identity, and there is an Euler's formula, and there is a De Moivre's formula. Or maybe I only want them to memorize Euler's identity is e to the I pi plus 1 equals 0. So I can pick, right? For an older student, I might look at a bigger chunk and say, I want you to, right? You've looked at these little chunks before. Now put those chunks together and see how much you can memorize. We can always help by guiding the repetition, right? So foundations, how many times do we need something to get the peg in before we start pounding it in there? 7, right? I just saw that 7 times, right? Anybody that's been in foundation 7 times. See it, say it, hear it, act it, say it again, hear it again, right? We read it, get it in those 7 times, but not 7 times and stop. 7 times is, if you think about like hammering a nail, if I've hit it 7 times, it's probably in there. It's got a good start that it's not going to fall out. And now I can pound it a little bit harder. So I have to keep practicing, but that 7 is what gets it started, and so that it's not going to fall out until I practice it some more. So we can guide that, right, for our younger learners. For our more experienced learners, we can assess, are you doing this, right? We can give them a little bit more responsibility for the repetition, but we want to assess that so we know that they're continuing to practice, right? Just like Kristen was talking about with the memory box, being able to say, even to her challenge age students, are you remembering this? Are you still practicing this? Let's go back and assess what you remember to encourage them to keep up the repetition.
I
Any
want to add
questions
that.
on?
Well, I want to add because this chart requires a whole lot of memoria because you'll notice that like we didn't define E, we've done that earlier and in the charts. We didn't define theta, we haven't defined I, we haven't defined R. These are things that you've already worked on, and this is a summation sheet of the formulas for complex numbers. So we've not like backtracked on this page and redefined all the symbols on here. So this is where pulling out the charts and or these memoria pages can help you see like where did I learn R? Where did I learn theta? Because they're the same definitions being carried through. We've tried very hard not to switch the letters on you.
Great. Here is our page 3, and there are your, Hallie, there are your vectors, and you can see them moving around in the plane so that we can use those to help students to visualize adding complex numbers, because we do have the 2 parts. So the vectors help us to visualize that I have to add my horizontal parts together and I have to add my vertical parts together. Are there any questions from these pages? And then on day 4, our final frame page is our careful calculations. And especially, I think, again, as we're rounding out the year's work, this is a great place to say, you know what, we still are struggling with our 12 facts, or my students are still struggling to add double-digit numbers. And so this is a great opportunity. These pages, the careful calculations pages, are a great opportunity to use these as a model for your students to practice by you choosing the numbers. So for example, if we look up here, if you know that your students are having a hard time with numbers that are bigger than 5, maybe you take this and you go, all right, well, the math map wants you to practice 6 plus 4i plus 3 plus 5i, but I want you to practice 9 plus 8i and 7 plus 6i. Right? So you could create your own problems to practice the specific computation facts. And again, we've talked about it several times, using these pages as a form so that we're still practicing within that form, but you can take and make these specific to the computation practice that your student needs. And here is our page 4 that we're taking a look at here. And there's some big ideas in this unit that we're building up to that are really kind of beautiful. I'm just going to take a minute to talk about the fact that when we are in lesson 8, we talk about the fundamental theorem of algebra. And we say that there are n solutions, right? If there's n, if it says the nth root, well, there are n roots of that number. But most of us have only ever looked at them in the terms of real numbers. So we say this, but we don't really get to see what it looks like. And even for students, and for those of us who perhaps did some more advanced math and we really took a look at solving quadratic equations and solving polynomials, that we would take a look and we would learn, oh, that we would either get real solutions or complex solutions. And then we would throw those complex solutions out because we only cared about the real solutions because we were always graphing on a real plane. And I don't think that I ever, in any of my studies until I started working on the math map here, ever really graphically saw what are the seven, right? If I said the seven roots of seven, what are they? I've never heard about those before. But this lesson takes this idea that we hinted at back in lesson 8, and we talk about it in the real plane. But now we go, okay, so what are those roots? Right? It kind of brings the fullness of the numbers together. Because if I say what's the seventh root of 7, and there have to be 7 of them, right? Well, it turns out there's one real and there's 6 complex roots. And if I don't ever look at the complex plane, I never get to see those. And you can see this is what we're building towards. Do I expect that an integer student is going to see how beautiful that is? No. But I do hope that maybe our expressions and transcendental students are going to go, oh, this thing way back then, look, these are what those numbers are. And I can actually see where they fall and why only one of them is real. So I think it's really cool. I know it's the end of the year, and so that may not happen for everybody, but I don't think there's any other math curriculum that even provides the opportunity for students to see that pattern and have that discovery. So I'm kind of excited about it.
Like your all's opinion, because I feel like going over 25, 26, and 27, if you only even just looked at the I pages and not even the charts, then the charts would be better. It should answer the question, are we going to cover the material for like college entry or for engineering or for subjects, like that? Um, True? I mean, is this advanced information for most of you?
Yes, sí, mucho, like all the languages, yes. Like this is definitely, definitely advanced. I think my behind the question of whether it will get covered is whether or not the students will have enough time to fully understand it. It's the
Hmm.
am I supposed to really get this in 1 week type of thing. And
Hmm.
so
So yeah,
for
I appreciate that. And that's
for
again why the
those of us
math is, I would say that's why the math is actually mapped so
who are
that like if you only got through the fractions in week 27 in understanding, you'd still be really ready for engineering courses in college.
I
that's very helpful.
Yeah, and
Yeah.
I was just thinking, Lee, one of the questions that I sometimes want to ask people when they go, well, is this in there? Is this in there? Is this in there? Like there's some magic,
Mhm.
that if we went through the right math curriculum, there's some magic formula. And my question that I always want to push back on is, what do you remember from your high school math? Right? And for most of us, it's it's a little bit. It's a little bit, and it's kind of whatever the last thing I practiced is probably what I remember. So if you went through calculus, you've probably forgotten all of your geometry. Let's face it, most of the geometry you forgot because you did it 3 years ago. So you may remember some of your algebra manipulation because you practiced it in calculus, but you know what? You probably don't remember that week that you spent on logarithms. Yeah, you probably don't remember that. Most of it we don't remember, right? So Hallie, you're in the sciences, right? You teach
Yeah.
sciences.
Yes. No, I
How think about your students. How many of them are coming out of traditional education and they know a fraction of what is in here?
yes. No, this is advanced, Lee, to answer your question. I don't know. I'm sure I learned imaginary because it wasn't unfamiliar when I first saw it, but I couldn't have defined it. And I remember when we got into the trig, I remember thinking the only thing I remember is Sakatoa, but I couldn't even tell you what it meant yet until I reviewed all the triangle information. So, but I've also had more math than most. Yes, I teach chemistry. So I haven't had to review complex or imaginary numbers probably since I took it back in 25 years ago.
And for people who never got that far or didn't believe me, Saxon covers all this material very well in the advanced math book. So that's a place where there's similarity in content, not in approach, but in content. And why I
So
love
that's
Saxon. Go
So
ahead.
that's where I was going with that, is that we can sit here and go, yeah, we all saw this. And most of us, even though those of us who continued on in some branch of mathematics or science are going, yeah, I don't remember it, or it rings a bell, but I couldn't tell you anything about it. And so the difference between that traditional approach and what we're doing here is that we're emphasizing the language. So that a student who has gone through the math map, I mean, wouldn't it be amazing? Wouldn't most of us be happy if our students graduated and they could tell you what sine, cosine, and tangent were, kind of what they meant, if they could tell you what a complex number was and what I meant, and that they were two-dimensional, right? We would have pretty low expectations if we really sat and said, and that's what the math map is going to do, is it's going to not just have said we touched on it at some point in 13 years, but they are going to graduate because it's the classical method, right? Not because it's the math map. I want to be clear. I'm not making this claim because it's the math map, but what does the classical method emphasize? It emphasizes really getting that grammar learned well so that it sticks with us and we can continue to make connections. And so if we take that same approach and we apply it to math, our students are going to actually remember some things that they're learning and be able to take that and make connections and succeed in wherever God puts them. And so it's that classical approach that is saying the language is what matters. And so when we look at these lesson pages, don't stress over, did you see the patterns or did you get this or that, right? If your student goes, oh, well, yeah, it's just the imaginary number and it equals the square root of -1, I would call that a win. So,
Well, and I also think that, you know, even though it's 4D, but and we haven't gotten the math map up to challenge 4 levels, that there's so much in just learning the slope and the area for, the rate of change and the accumulated change is so beneficial and would be great review for all of our challenge 4 directors who haven't gone through the math map yet. But that's why I'm going back and looking at all the 4D stuff and just reviewing it, because we're getting ready to go into accumulated change in physics. So it's been very helpful to just review that. So thank you. Appreciate it.
that's great.
I also want to bring up, because we have Haley here, she might be able to add to this. The word conjugate's super important across all of academics. So you conjugate in Latin and in math and in English and in chemistry. Isn't that right, that they're conjugates to various elements? Christine's nodding.
I
Yeah.
wouldn't use the term conjugates, but you pair
Mhm.
common and opposite things. I'll try to make it
Yeah.
sound the most simple.
Mhm.
Yes, and I am seeing in the math map areas where if it is learned application in the sciences, whether chemistry or I'll even pick on biology, are easier. And just to pick on biology, because that's usually more popular than chemistry. I'm a chemist. Sorry if you did not know that. But there are a lot of comparisons of looking at diagrams in biology in a two-dimensional world, two-dimensional picture, and now we have to apply it to a three-dimensional world. And that alone, learning through the math map, comparing different visual representations, I think will help you see. Even the cover art for this week, it's trying to show what I would picture in my brain as a three-dimensional round thing on a two-dimensional surface. And so that wasn't that was more than you wanted, but the conjugates, yes. Pairing things. No, it's there. It's all there.
Well, even for me in the medical field and looking at, for instance, allergies to medications, and we have to look at these beta-lactam, I guess, chains that are off of the main structure to determine whether a patient could react to a different medication that we're providing for them, is still making comparisons and connections like we are learning how to do throughout all of our education. And it's so beneficial to think of the patterns and to see those, to see those patterns in the medications and how they were made, from these medication companies.
So at the beginning, Lee talked about the slide, and I think this is the one you were talking about all the support that we offer. And sometimes it's overwhelming. We had this conversation this week that it can almost be too much help sometimes because you don't know where to start. And my response to somebody was just jump in, right? Don't feel that you have to go back to book club 1 and start from the beginning and catch up. Just start this week, start next week. You can just start where you are. And as you gain familiarity, you might go, oh, I wonder if they've talked about this in a book club. Then you can email Babs and Babs will say, yes, here, watch this book club. Go back, here's the link that you're looking for. So there is a lot, but the best thing that any parent can do is just engage in the conversation. It doesn't matter where you plug in, it doesn't matter how, but engage in that conversation. Because if you're engaged in the conversation, you can now invite your student in and engage with them as well. And that's where we build our relationship. Whether it's engaging in a common conversation about mathematics or the Bible, right? We find these places of commonality that we can engage together. And the math map is what's going to allow us to do that with regards to math. It gives us that point of commonality. And the more that we immerse ourselves in the conversation, the more we're going to be able to bring all of those pieces in together. So we do have 3 weeks left. Next week, we're going to be talking about lesson 28. And then in lesson 29, that's our Seeing the Unseen. I would really love it if you would bring a testimony to share, or if you watch us recorded, please send us a testimony of how you have seen the unseen this year, because we all have them. We all see the unseen in a regular if we're looking for it, right? If we're seeking God, he's going to reveal himself. He promises that several times. And so bring those testimonies, because I think it's really encouraging when we see how each other are seeing math differently and seeing God through math. Then our last week for lesson 30 will be Lee's birthday, April the 1st. And then after that, we will start our summer series that we're excited about. So we had a couple of questions that were sent in. I think, Hallie, you sent them in. And the first one you had was thinking about the box and whisker plot for 2 different age groups. And my simple answer would be that depending on the age group is going to determine how many numbers that I use. So for a young student, I would use 7 numbers so that I can say what the middle number. And if there's 7 numbers, there's only one middle number. And so they can find that middle number. Then I'm left with an odd number on either side. I have 3 on either side. So when I say find the middle again, it's easy for them to find the middle. And that helps me to find my Q2 and no, my Q1 and Q3. So for younger students, I would emphasize just number sets that have 7 numbers, putting those in order, and then say, okay, what's my smallest? What's my biggest? What's my middle? Okay, now look at the ones that aren't the middle. What's the middle of those? And with 7 numbers, it always works out nicely. As my students start getting older, I would progress to bigger numbers, bigger number groups. I'm not sure if there was more to this one here, but as we look at a bigger number group, just turn on the pen.
So we pretty much introduce each of the lessons with a 5 or 7 to make it easier for them. And then we go on to using like decimals and 6 numbers in the last couple of problems. So I would assume every year, even though if you've gone through all the years in the math map, like when I go to do one of these box and whiskers, they're not necessarily difficult, but boy, I have to think about it every single time. And so I don't want people to think they're going to necessarily just get easy. They're not. You got to think about what you're doing.
Yes, the reason I said this in is because I was like, you're just picking numbers. And then I was fumbling trying to say like, well, how? And what you said, Christy, was perfect. So we start by having the 7 in a row in a series, and then we find the middle, and then we go and get that Q1, Q3, or I should say quartile, if I'm saying that right.
Yeah. So once we have 8 numbers, right? That's where I was saying with older students, we'd start stepping up, because now I would say, well, I have 2 numbers that are in the middle, 4 and 5. So I have to find their average to find the median. So that would be 4.5. But now, because my median, right, I'm going to split. So as soon as I get 8 numbers, notice it's a whole different ball game, because now where I excluded my 3 when I had 7 numbers, because that was my median, since my median is 4.5, I don't exclude 4 and I don't exclude 5. So I have 4 now on either side. And so I have to find the average again of those. And so we see how just going from 7 elements to 8 elements changes what we're doing drastically. And so that's how I would always start with those 7 for my younger students to help them see. And then I would step up and go, okay, well, what if we had different numbers? And then eventually I would encourage a student to go and get a huge data set, go download a data set from somewhere and count them and find your middle and do the whole thing, right? That would be the ultimate. So that transcendental student, I would say, go find a data set and find the 5-number summary and then plot your box plot so that they'd be able to see that. We admittedly have not done as much statistics in the math map as I would have liked us to do, because I really enjoy statistics. But we're introducing the grammar of that. So if you have a student who really enjoys statistics, that's a great thing. Again, that transcendentals year that they can go and start looking at different graphs and comparing different graphs and talking about, well, how's the data been distributed? How do I know that based off of what my box and whisker plot looks like, right? There's a lot of conversations that you could dive into with students who are interested. But we are trying to mostly just give them the grammar so that they can go and have that conversation or that exploration if they want to.
Percy, I would love it if you explained the C22-4 and how you arrived at those numbers. That would be a good teaching for us to have.
So looking here, if we count, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 values. So I am going to have a middle. So I would have 1, 2, 3, 4. 9 is my middle, and I have 4 after that. So there's my 9. All right, that's my median. Now I have 4 left. Since that value is my median, it is not included on either half. So now I just look at those 4, and my middle two both are 5s, so their average is 5. Right, so that's my Q1. And then here I have 2, and so 12 and 18, their average is 15, so that's my Q3. And then my minimum is my 3, my maximum is my 21, and that gives me my 5-number summary.
So what I like about that is, like when I first looked at this, when you pulled it up, I'm going right to the graph thinking that's where I get my answers. And it's not the graph, it's always the set. And that's a common error, I think.
Kirsty,
So thank you.
Nicole asked in the chat, do you recommend a statistics curriculum for high schoolers?
I mean, if you wanted to do statistics on top of this, I'm just looking to see if I have it here. I taught out of a book called Statistics, Concepts, and Controversies or Controversies, which I really liked. It was not a math book. You use math in it, but it was more the concepts of statistics and did a lot of work that tied it to science. So if you're looking for, there are some really great books. So for a high school student, if you're looking for a statistics research, I would not look for one that is like a college prob stats book that's emphasizing the math. I would look for one that's more tied to the science, and how statistics work in science, because that's really where the power of statistics comes from, is understanding the difference between the descriptive and the inferential statistics. And again, we're giving students the vocabulary, the grammar, a little bit of that here in the math map. But if you were looking for something more, that's the type of resource I would look for, that would talk about what does it mean to sample, right? When we graph things, and we have to understand the normal curve. So, right, Hallie or Kristen would both know this, that when we test things, and so if you're thinking about your testing your hypothesis for science fair, we always are going, how unlikely is something? Science is never 100% certain. We're going to talk next week that math proofs are 100% certain. We know that that is truth. A science proof is always talking about how confident am I that this is a good answer, right? And so if I say, oh, I'm 99% confident for a drug, that might be good. If I want to make sure I pick the right color, I might be happy if I was 80% confident that I got the right answer. And so when we think about statistics, if you're looking to add something in, I would look to add something in that's going to be that bridge between the science and the math, and not a math statistics based course. Because if students are going to go into statistics in college, they'll get all the math that they need, because it'll all be calculus based. But that's so. Do you have to? No, you certainly do not have to do that. But if you have a student who's really interested in science, who's really interested in learning more and being I think statistics a lot of times is being a good consumer of information, knowing how to read things that are being given to us. I remember the first year that I taught the class, I would have my students bring in examples of statistics. And one of them came in and they said, I'm pretty sure on the radio this morning that they said that you could lose 100% of your weight, but that would be a bad thing, wouldn't it? And I was like, yes, that would be a bad thing. And so there's a lot of advertising, and so understanding statistics sometimes is just being a good consumer of information. So that's probably way more than I needed to say, Nicole, to answer that question. But if you were to add something in, that's where I would do it. I think it'd be a great summer study for students who are interested in pursuing more of the sciences, or if they're into debate and they're pulling in statistics. Again, it would be a good summer type of study that you could add in. All right, here's another question that was matching curves, and sometimes these axes of rotation and these curves match really, really well. And sometimes we're trying to give some examples just to get us thinking, and they're not a perfect match. So on the top row, I think most of us would probably agree that most of these are a pretty good match, right? That if I was to take and rotate my water tower, the top part is going to be a great match, right? Because it's circular. So if I rotate that around, it's going to be a great match. My legs, not as perfect a match because there's only 4 of them. And so if I was to rotate that, right, I'm not getting a solid. Our cone, that's a pretty good rotation, right? Because it's circular. My egg, if it's nice and symmetric, right, I'm going to see that it would rotate around itself pretty well. Our orange, minus the leaf, right? My orange is probably pretty close to being a nice sphere. But if we look at it, if we were to take an orange, it would probably land in our hand and stay there and not roll off because it's a little bit flat on the bottom, right? So is it a perfect rotation? No, but it's close. So the question was specifically looking down here at the bottom. And these are not perfect. They certainly are not a perfect match, right? Because here we have this curve. If it was rotated, I'm going to get some kind of a circular thing, and a barn isn't circular. But we can see that this sort of shape matches this sort of shape. So it's not a perfect match, but it's a close match. That my
See, I
dress,
wanted to say, I'm pretty sure we changed that one out for the future editions because it was
okay.
causing people confusion. But go ahead, you're on a roll.
I was just gonna say, and my banana again, right? If I was to really to rotate that banana, I would really end up with a bowl shape versus the banana shape. But we're just asking students, just especially at these younger ages, just to start thinking, well, which ones of these match? And then I think that as you see here in complex, we're getting a little bit closer to being the shapes really matching more what those solids would look like. So does that help any? They're not perfect matches. We're not looking for a perfect match, but just where do you see that shape reflected there?
Part of the problem, the opposite axis, that people didn't understand that this is around the y-axis and then this is around the x-axis. That might be an issue.
Yeah, I think, well, that was one issue. It was also trying to visualize if this gray thing is turning. The one that matched the banana, I was totally lost. My son saw it for what it's worth. He was like, it's obvious, but he couldn't tell me why. And I said, but I don't understand. And then the dress, I was like, why is the curve, like the dress has an inner waist? And now that I see that that is the answer, I can see that inner waist as closest to the origin, the gray part close to the origin on the dress. And that curving around would make the dress with the waist.
And it's like it really probably should be a flat neckline because the curve doesn't represent the interior of the dress, just the exterior. And that's the same with the banana. It's just that if you rotated the exterior.
I think that's a great example of where kids look at it and they go, yeah, I can match that. And then we as adults are a little bit more granular, a little bit more exacting, and we can, well, it doesn't match. But it's okay. We're just trying to get the kids to take that 2D sort of shape and think about what would it best match to. All right, Nicole, what can't you see?
I think I just don't see how they match. I don't get it. I just don't get it. It's not
Turn
clicking.
the banana into a bowl and make the dress a strapless wedding dress, and you then
So
it'll
if I
have two
if I
triangles.
right here, here's my curve. If I could rotate it around, I'm going to end up with it's really going to look more like a vase, right? It's going to look a little bit more like the vase does here, but it's going to have that same sort of fit and flare shape as the dress, right? So,
Mm.
I mean, if we took something that was one dimensional,
Mm-hmm.
right? I'm going to change my to a pen. Let's take something that's one dimensional, but in the 2D plane, right? And now I just want to take this and I'm going to drag it and rotate it just in the plane. So if I rotated it around to here, right? And this is going to rotate around, right? If I said, what would that rotation look like, right? As I'm sort of dragging this around, we see that it's kind of filling up that space. And if I kept going, eventually it would make a disc and it would fill up that disc. That segment would create that disc if I was to rotate it all the way around. But now we're taking that idea and we're saying, okay, well, what if we did that in coming out of the page? Right. So now instead of it making a flat shape, it's going to come out of the page and make a 3D shape.
Are integrals used to
And
solve volumes of these shapes in the upper levels? Am I speaking truth?
Yes, that's what we're working towards here. And actually, one of my favorite videos that I made is on the main math map page in the companion. If you click on, don't click through to the booklets, but click on that left-hand side where there's some little videos. I did a little video. It was right after I got my my apple peeler, and I was peeling my apple, right? And that's exactly what that integral does. Is it saying I'm going to take slices and I'm going to calculate areas and I'm going to add all those areas up, but they're going to be areas of the slices instead of areas of rectangles. And so that's that works best when we're thinking about these solids of revolution, because they're all going to have circular cross sections. That's the goal that we're getting to there, is the idea that it would have a circular cross section. In one direction or the other, right? So a lot of these have circular cross sections going up and down because they've been rotated around the y-axis. If they've been rotated around the x-axis, they're going to have circular cross sections going left to right.
Doesn't matter which axis you're talking about rotating around, because the 1D on a 2D made sense to me, but the coming up off the page, I can't quite see it yet. I guess I just need to sit
I
with
wish
that
I
for a
could
little while.
I have like a bubble wand, right? I feel like if we had a bubble wand, you could see me like dragging the bubble wand around. So think about this.
Oh,
If my arm, right?
I was thinking the Tron car with the light thing in the back.
So if I take my arm here and I rotate it this way around, right? Track where my arm is going, and if that all filled in as I go around, I'm going to end up with a solid that is going to look kind of like a bowl, right? It's going to look like this as I go around. But if I took that same shape and I went around the x-axis, it's going this way now.
Okay.
And it's going to look more like I'm creating a megaphone off to that side. So the axis that I choose, I'm going to be rotating a different way. So I could either go from having a bowl because I rotated it this way, or a megaphone because I rotated it this way. Does that help
Gotcha.
a little bit to visualize that?
That Yes, that helps a lot. I just can't get the dress one. The dress one is throwing me for a little, but I can sit with it for a little while. You don't have to
It's
stay
a
with me.
dress.
All right. Well, are there any other questions? Did anybody bring some questions that they would um, like to ask or bring up or go through?
Okay. Kirsty, I need to leave because I have another meeting, but you guys keep talking. That was a fun hour. Thank you.
I always ask these random questions at the end, but interestingly, when you were showing the cover page, my eye went to the circle with the week number in it and the fact that it looks like a compass rose tilted. Why did you tilt it?
That is very interesting because we actually talked about tilting it back to true north. And I think so when you go back 9 years, right, we started talking about things and then we said we need a name for this and we came up with a name. And then we had somebody who worked with us for a brief time who was a designer. And so she came up with all kinds of really fun things. I mean, at one point, the math map had like a pirate map background, it was all parchment paper, fun. And then she, I think, was the one that came up with the idea of like having the compass, right? The idea of a map and a compass. And I think it was a space issue that it just was like, oh, it looks better if it's tilted. And it stuck. And then by the time we talked about rotating it back to be true north, um, we're talking about 390 booklets and what 20 of those pages or 24 of those pages have, so it was a lot of work and we just said, you know what, it looks fine the way that it is. I wish I had a better response, but you know, that's basically what happened there.
That sounds like curriculum development with lots of pictures. It's hard to change all these iterations of it.
It is. Yeah, there's so many things that you think, well, if we could go back and fix it, we would have done this differently and that differently if we'd known then what we know now. But any other questions? Well, thanks everybody. I really appreciate you being here. Keep sending us your questions. I love the conversation. I love it when we wrestle with these ideas together. So please do. And then again, I'm excited about our summer series. One of the things that we're going to start off with is talking about what is a unit, right? And I think when we looking at this lesson where we're talking about I is the imaginary unit. So we're just counting how many of these units, right? How many water bottles, how many popcorn bowls, how many daisies, how many matchbox cars, right? Whatever it is that we're counting, that's our unit. And when we're looking at numbers, our unit is that hidden one. And so I think it's going to be great conversation just to talk about what is a unit. And when we talk then about comparing like units, converting units, it makes more sense when we all think, oh, right, that's what we mean when we talk about units. So our first week is going to be just talking about what is a unit. And then the next week, we're going to talk about how do we count units and looking at place value. So I'm excited about this series. I think it's going to be something that can be a blessing. So I hope that you'll all come and keep going through the summer with us. And until next week, have a great week.